Right guys, today we're going to have a look at the sodium thiosulfate titration. This came up in 2015 as question 1, and the first 3 parts were basically like all other titrations, looking at some of the theory around the particular titration. I'm going to have a look at part D because that's looking at the calculation part. Part E goes on to another part of theory, so it's just part D that I'll be focusing on. So if we look at the question, it says given that there were 6.35 grams of iodine, I2, in 500 centimeters cubed of the iodine solution, calculate firstly the number of moles of iodine in each 25 centimeter cubed portion. So we'll start looking at that. So first of all, we have been told that there's 6.35 grams of iodine in 500 centimeters cubed. So if we've got 6.35 grams of I2 in 500 centimeters cubed, what we like to find out is we like to find out the moles per liter. So this is grams per 500 centimeters cubed. So I'm going to first multiply this by 2, and that will give us 12.70 grams of I2 in 1 liter. The next thing that we're going to do is we're going to divide by the MR, the relative molecular mass of I2, to find out the number of moles, because the number of moles is equal to the mass in grams divided by the MR. So in this case, I2, we're talking about I2. We've got the mass in grams, 12.70. The MR of I is given on the exam paper. It's 127. Now you have to multiply that by 2 because it's I2. So that's going to give us 254. So if we put 254 there and work out 12.70 divided by 254 gives us 0.05 big M. That's moles per liter. We've got it into moles and we've got it into liters. So it's moles per liter. We've got 0.05 big M, which is moles per liter, molarity, sometimes MOL. So once we've got this figure now, we can go on to our table. We're looking at I2, which is our iodine, and we're looking at S2O3 to minus, which is our thiosulfate part. So if we use our table, we use molarity, and then volume, then our actual number of moles, and then the ratio. So this is the table that we use for all of the titrations, which is handy because along the way, this method is called the method of first principles. Along the way, we find the actual number of moles that are reacting. We've just calculated the moles per liter, or the molarity of the I2. So that's 0.05, and I'm going to put in big M, just so I remember that it is moles per liter. If we look at the question, it says that there are 25 centimeters cubed of the iodine solution used. So 25 centimeters cubed goes there. The ratio number down here then is taken from the balanced equation. So we see that there's no number in front of the I2, which means it's just 1. And the number in front of the thiosulfate here is a 2. So we'll put a 2 there. What we're next going to do is going to find out the actual number of moles in the 25 centimeters cubed, which is the answer that they're looking for in part 1 of this question. So in part 1 of the question, they say find the actual number of moles present in the 25 centimeters cubed. So we know that there is 0.05 moles per liter. We don't have a liter. We've got 25 centimeters cubed. So we're going to divide by 1,000, and then we're going to multiply by 25. So 0.05 divided by 1000 and multiplied by 25. And we get the answer of 0.00125 moles. And that's the answer there for this one, 0.00125 moles. And then on to part two. Part two of the question says the number of moles of sodium thiosulfate required to reduce this quantity. So we're looking for this number here. And the way that we go from this side across is that we use the ratio, and that's why ratio is down at the bottom. So we start at molarity, we work it out into actual number of moles, then we use the ratio to cross to the other side, and then we can work our way back up. So we've got a 1:2 ratio. So if we've got 1 here, we've got 2 here, we need to multiply this by 2 to get this value here. So we're going to multiply this by 2, not too difficult, 0.0025 moles. And that's the answer here, 0.0025 moles. And that's the answer there for part 2. What you will notice is that you don't find these, if you were to use the formula method, V by M over N equals V by M over N, you don't find the actual number of moles along the way, and you kind of skip this step and you go straight to this step, this value. So the first principles method is better because then you can actually find the actual number of moles along the way. You can think about what you're doing while you're doing it. And the other thing is they've started asking what are the actual number of moles along the way, so you need to be able to calculate it. If you look at part 3 of the question says the concentration of sodium thiosulfate in moles per litre of the 17.85 centimeters cubed which were required to reduce 25 centimeters cubed of the iodine. So what they've told us there is that this value here, 17.85 centimeters cubed. So we know that there's 0.0025 moles in 17.85 centimeters cubed. We don't want the moles per 17.85 centimeters cubed. We want the moles per litre. So in part 3 of the question, we're going to take this value, 0.0025, going to divide by 17.85, and we're going to multiply by 1000. It's exactly the same as what we did up here, just in reverse. Here we divided by 1000, multiplied by 25. Here we're dividing by 17.85 and multiplying by 1000 to get it back up to moles per litre. 0.0025 divided by 17.85 and multiplied by 1000, and we get 0.14 big M, which is moles per litre, which is the answer there for part 3. The final part of the question, part 4, is looking at the concentration of the sodium thiosulfate. We can put that value in there now, 1,4. So the concentration of the sodium thiosulfate solution in grams per litre of its crystals, and the crystals are Na2, S2, O3, and then there's a 5H2O. So this is the entire crystal. It's just this part of that crystal, which is this part in here, is the active ingredient, you might say. But when we weighed it out on the scales, we had to bring the whole crystal with it. We couldn't just bring the active ingredient part, so we need to find the MR of the whole part. So I'm just going to work out the MR, the relative molecular mass. We've got 2 by 23 there. Sodium is 23. Sulfur is 32, and we've 2 of those. I'm going to add these up. Oxygen is 16, and there's 3 of those. And then water is 18. There's 5 18s there, which gives us 90, 48. That is 64, and that's 46. And when we add all these up, 46 plus 64 plus 48 plus 90, we get 248. That is the MR of the entire crystal. So we know the moles per litre. We know the moles per litre is 0.14 moles per litre. So if we multiply by 248, we will get the grams per litre, which is the question that they've asked us. Multiply by 0.14, and we get 34.72 grams per litre of the crystal.